Indirect fire from mortars, missiles, and artillery shells is a very serious concern for armed forces in battle. But thanks to the point defense systems like the CRAM, indirect fire of this nature may have met its match. The CRAM, standing for Counter Rocket Artillery and Mortar, is an air-to-ground missile defense system that detects and destroys incoming rockets, artillery, and mortar rounds before they reach the ground. It uses a powerful machine gun that can fire up to 4,500 rounds per minute and take down close-range rockets as well as missiles and artillery shells. CRAM was created by U.S. weapon manufacturers to assist the U.S. Army in countering insurgent and militia missile, mortar, and drone attacks in Iraq and Afghanistan, both places where the U.S. had waged a war after its 9/11 attacks. The CRAM weapon system is a system of systems that has intercepted incoming rocket, artillery, and mortar rounds at forward operating bases and important targets in Iraq and Afghanistan, according to the U.S. Army. It saved the U.S. Air Force from what were the most horrific and exhausting days at Kabul for American forces. The Federation of American Scientists Military Analysis Network, MAN, defines 7 CRAM functions: sense, alert, reply, intercept, command and control, shape, and protect. CRAM has a naval counterpart from which it stems. This counterpart is called the Phalanx Close-In Weapons System, or CWIS for short. CWIS proved extremely successful at deterring incoming artillery as well as opposing gunboats. As such, the military concluded that a land-based variant of the system was needed. The CRAM was then developed, and it has since its inception protected many sites from artillery fire. CRAM finished development, integration, and testing in April 2005 using this system of systems strategy. Unlike the CWIS, which is permanently fixed on a ship, the CRAM is mounted on a trailer and fired remotely. It gives it a lot more flexibility and agility. When a threat's identified, the weapon system identifies, evaluates, tracks, engages, and assesses battle damage automatically. One key distinction between CRAM and CWIS is the use of self-destructing shells. While CWIS operates at sea, where the possibility of friendly fire is remote, CRAM is used on the ground in close proximity to the very forces it's stationed to protect. CRAM rounds are designed to detonate after a certain distance, preventing them from flying several miles and eventually striking the ground. To avoid collateral damage on the ground, CRAM employs additional tracking sensors, such as the lightweight counter-mortar round and Q-36 target acquisition radar from the U.S. Army. They also provide a warning system for forces nearby. Both CRAM and CWIS use the M61 Vulcan Gatling gun. The M61 is a 6-barreled 20mm cannon with a typical rate of fire up to 6,000 rounds per minute. Developed in the early 1950s, the gun was standardized as the M61 in 1956. The U.S. Army used the M61 and the M167 and M163 air defense systems, and as the primary gun system on the F-14, F-15, F-16, and F-18 fighters. The gun's also used as the tail gun on the B-52H bomber, while a lightweight variant is used on the F-22 Raptor fighter. As you might expect, such a sophisticated piece of kit does not come cheap. Each CRAM system costs somewhere in the region of $10 to $15 million, depending on the final spec of the units purchased. But that's only the cost to initially acquire the technology. With such a massive rate of fire, this unit literally burns through bullets. Depending on the number of munitions spent, a typical engagement with a single missile could range between $30,000 and $60,000. The U.S. military has only one other weapon system that can outshoot the Phalanx in terms of rounds per minute. This is no other than the M134 minigun, which can dish out 6,000 rounds per minute. However, the M134 minigun, which can be mounted from helicopters to Humvees, shoots the 7.62mm round, which is almost half the size of the 20mm. A CRAM system is composed of several components, which are all essential to its successful operation. The primary components include a radar system that detects the incoming enemy projectile and provides information on its location and trajectory. Missile launch platforms are also necessary to allow for a quick counter-reaction time when deployed. Other components of a CRAM system may include infrared sensors, computers, communication systems, and reactive methods such as weaponized smoke or decoys. A CRAM system protects land-based assets from airborne threats, such as aircraft or drones. A CRAM system can accurately detect and track projectiles when equipped with the proper components, allowing for an effective countermeasure response. It can also provide early warning of an attack, giving personnel time to take shelter or react appropriately. Overall, a well-managed CRAM defense system can significantly reduce the risk of destruction from enemy forces. The CRAM weapons system has some other perceived weaknesses too. For example, it takes around 5 seconds to acquire, lock onto, and engage a threat. It also has a fairly short effective range of between 100 and 1,000 meters. These weaknesses aside, it's shown itself to be one of the most effective anti-missile, mortar, and artillery defense systems in the world. For this reason, it'll likely remain an important player for many armed forces around the world for many years to come.